Alright, good day everyone. So you're welcome to this week's class. So this week we'll solve some examples to illustrate some of the things we have learned so far. So I have written some questions, some examples. Question 1A, 1B, 2A, B, C. So I think these will illustrate some of the things we have learned so far. So the first one says consider the matrices. I think I've written it here. 1A, consider the matrices A and B given as A equals this, which is a 4x4 matrix. B is also another 4x4 matrix. So the question is write a Python program to find A transpose plus the transpose of B, the matrix multiplication of A and B, the determinants of A, and the eigenvalues of B. So to solve this, we first create the matrix A, the matrices A and B. So we can import matrix from NumPy. So from NumPy, import matrix, so that A equals, let me increase it, so that A equals matrix. How many rows? We have 4 rows. So row 1, row 2, row 3, row 4. So row 1 we have 2, 4, 0, 3. Row 2 we have 6, 7, 2, 6. Row 3 we have 7, 7, 6, 2. And row 4 we have 9, 2, 6, 2. So that is the matrix A. What about the matrix B? So the same thing. First row, second row, third row, fourth row. The first row we have 6, 5, 4, 2. The second row we have 4, 0, 3, 9. And we have third row 3, -2, 2, 2. And fourth row 1, 0, 1, 1. So these are our matrices, and we can print them. We can say print matrix A equals A. We can also print matrix B. So print matrix B equals B, and we run. So this is matrix A. So 2, 4, 0, 3. Okay, 6, 7, 2, 6, 7, 7, 6, 2. So just to make sure that it's correctly written, so you should check that the matrix you are given is the same thing as the one that you have coded. So 6, 5, 4, 2, 4, 0, 3, 9. So I think it's good. It's okay. Then we proceed. So we can mute this. So the first part of the question says that we should find the transpose of A plus the transpose of B. So we first need to find A transpose, which is just A dot transpose. The same thing with B transpose. Sorry. So the transpose of B is just B dot transpose. So we can now print the results of A transpose plus B transpose. So print A transpose plus B transpose equals AT plus BT. So that is the first answer. Okay, before we print this result, we can print A and its transpose. So let's print A, then let's say print transpose of A, so that we'll visualize our matrix. Okay, just to make sure that everything is okay. So A is 2, 4, 0, 3, okay, and the transpose is 2, 6, 7, 9. So I think it's okay. So the code is okay. All right. So it's always good to check your results. So we can print the results. The first results, the sum of the transpose of A plus and transpose of B. So that is that. Then the second part, the matrix multiplication of A and B. So we use the dot function. Okay, the dot function. We have done this earlier. So we say print A multiplied by B, that's the matrix multiplication of A and B, equals, so it will be dot A comma B. So this will give us the matrix multiplication of A and B. Okay, so that is when you multiply A by B. Then the determinant of A. Now to get the function dit, we need to import the function from numpy.leanurge. So from numpy.leanurge import dit, which is determinant. Okay, so we can print the result as well. So print the determinant of A equals, so det A. The determinant of A, the determinants, because there will be 4, there will be 4. Okay, because we have a 4 by 4 matrix. So the determinant will be 4. So det A. So the determinant of, sorry, it is the eigenvalues that before. So the determinant is just 1. So the determinant of A is 1. Sorry, the determinant of A is 1. So, but the eigenvalues, if you want to find the eigenvalues of a 4 by 4 matrix, there will be 4. If you want to find the eigenvalues of, so this question, the determinant, sorry. You want to find the eigenvalues of a 3 by 3 matrix, then you have 3 values. But for the determinant, it's just 1. Sorry about that. So the determinant of A is 78. And you can check manually if the answer is correct, but you can rely on Python function det to correctly give the determinants, because it's not easy to manually evaluate the determinants of a 4 by 4 matrix. Okay, you can manually evaluate a 3 by 3 matrix, the determinants of a 3 by 3 matrix. Alright, so the last part is the eigenvalues of B. So there will be 4. Now we have a function under numpy.leanurge called EIG. It calculates both eigenvalues and eigenfunctions. It calculates both eigenvalues and eigenfunctions. So the first set of results will be the eigenvalues, and the second set of results will be the eigenfunctions. So usually what you do is, if you want to use the EIG function, you say EIG val, that's for the eigenvalue, comma, EIG vec for the eigenvectors. So equals EIG, the eigenvalues of B, EIG B. So this EIG B will return the eigenvalues and the eigenvectors. So since in this question we are asked to calculate only the eigenvalues, so we say print the eigenvalues of B are, so EIG VL, or we can even write it in full, eigenvalue, eigenvector, eigenvalue. Okay, so this will return the eigenvalues of B. So the eigenvalues of B are 10.22, 0. So there are 4. 1, 2, 3, 4. Okay, some of them are complex numbers. Okay, so that's about the first part of the question 1A. Okay, so it's a straightforward question. Then 1B, sorry, 1A. Okay, so let me use, okay. Alright, so 1B, the following step function is known as the if side function. That's h of x equals 0 when x is less than 0, 1 when x is greater than or equals to 0. So implement h of x in a Python function, h of x. So they want you to use the name h for the function. Then test your implementation for x equals minus 12, 0, and 10. That's question 1B. Yeah, this is it. Alright, so this is the question. The following step function is known as the heap side function. So implement h of x in a Python function, h of x. Test implementation for x equals -12, 0, 10. So what we do is we create our function def and we name it h, capital letter H of x. Now there are two conditions. When x is less than 0, the answer is 0. It should return 0. And when x is greater than or equal to 0, the code should return 1. So you have to say if x is less than 0, okay, return 0. Else, if x is greater than or equal to 0, then return what? Return 1. So yeah, this is one way of writing the code. Okay, then the question says that we should test the implementation for x equals 12. So we can create an array of -12, or we can say print when x equals -12, then h of x equals, so that will be h of -12. Okay, this one way. Then when x equals 0, h of x equals h of 0. Then when x equals 10, h of x equals 10. Okay, so we can print the three results. So you can see when x is -12, the answer is 0, because -12 is less than 0. And when x is 0, h of x is 1, because when x is greater than or equal to 0, the function is 1. Okay, same thing with when x equals 10, the code should return 1. So it's correct. Okay, then 2a. Alright, so this is 2a. Write a Python function that returns the sum s equals summation of 1 over k from k equals 1 to m. Compute s for the case m equals 3. Okay, now so again what we do is to create a function that will return s. Okay, def s, and the function will depend on m, because m can vary. In this case, we were told to use m equals 3, so we can set m to be 3, but let me just make m to be general, to be an arbitrary value. Then k is from 1 to m, so we can create k equals a range 1, that is the starting point, to m, the end point. Then the step is 1. Okay, you know a range, so the starting point, where you should start, where you should stop, and the step. Okay, so here it will start from 1 and stop at 3 in step of 1. That is, then we can now say return, you should return 1 over k, but not just 1 over k, the sum of 1 over k. So return the sum of 1 over k. So that is s of m. So we can compute s for the case m equals 3. So print s of m. So let's set m to be 3 as we were told. What happened? Okay, we have not imported a range. From numpy, import a range. Okay, so 1.5. So, and we can test this for arbitrary values of m. So we can test this for arbitrary values of m. But I think before we do that, a range, if you recall, if you say x equals a range 1 to 5, okay, let's use step of 1. and you print x, you are going to get 1 to 4. So it means if you really need 5, then it means you have to add 1 so that you stop at 5. So the same thing here, you have to add 1 so that the code will stop at m. Okay, so let me delete this. So please take note anytime you are using a range. So let me open Spider. I think Spider. It's opening. Alright, so let's say from NumPy import a range. Okay, then we'll now say x equals a range. You can see start, stop, then step, and data. You can specify from the data type. Okay, but the stop will stop at n-1. So if you give 5, it will stop at 4. Okay, and so on. So you have to be very, very careful when you're using a range. So if you want to stop at 3, then you put 3 plus 1. Alright, so let's change this to an arbitrary value. I can leave this. Let's say for m equals 30, you can print the results. 3.999. For m equals 50. So you can print for an arbitrary m, 500, and so on and so forth. Okay, so it's not compulsory. So in you can use it for arbitrary value of m, but if we had specified 3 here, okay, so if you have set m equals 3 here, then the Python, even if it not specify m, Python will take the default to be what? To be 3. Okay, Python will take the default to be 3. Okay, let's just set m equals 3. All right, that is 2a. Next is 2b. 2b. So what is 2b? All right, this is 2b. Given that y of t equals v naught t plus half gt squared, with g equals 9.82 meters per second squared and v naught equals 20 meters per second. G is the acceleration due to gravity, v naught is the initial speed. So if t is 0, 1 to up to 20, write a Python code to calculate y of t for all values of t from 0 to 20. From 0 to 20. Write the results to a file. The file should have 2 columns. The first column should contain the values of t, while the second column should contain the values of y of t. The name of the file should be height.txt. Okay, so we are given some constants, g, which is 9.82, v naught is 20 meters per second, and we are told that t is from 0 to 20, so we need a range. So from NumPy import a range. So then we say a range. Where is the starting point? 0. Where should it stop? 20. The spacing 1. No, now this is 20, so you have to change this to 20. 20 plus 1 or 21. Okay, so that it will stop at 20. Truly. Alright, so we have to calculate y of t. Y of t is v naught t, so v naught times t plus 0.5 g times t squared. Yeah, so I think we have done that, so we can print y. So print height equals y. So these are the values. Now the second part of the question says write the results to a file. Okay, the file should have 2 columns. The first column should contain the values of t, while the second column should contain the values of y of t. So to write this to a file, so first open the file. So f, let's say f is the name of our file. Open. We're just this f is a variable. Okay, so the name of the file will be here. Let's say we are asked to save the file as height.txt, then write. We want to write to the file, so w write. We can now write into the file. So for I in range from 0 up to length of y. So then print t of I, okay, t of I, comma, y of I, then file equals f. Then we can close the bracket. Then we must close the file. Okay, also open the file. We have opened the file, we wrote on the file, then we have to close it. So f.close. Okay, so we can run this. I think we don't need to print this. Okay, so we have run this. Then, so to see the file that we have created, this height or distance.txt, you have to go to the directory we are working, and this is the directory. So this is the file. So the first part of the file is the t, that's the first column is t, and the second column is the distance y. Okay, the distance y. So that's about that. All right, so that's 2b. So lastly, 2c. So 2c. So this is the last question, 2c, for today. I'll still give other tutorial questions. These are simple questions. I mean, this is the first time we're treating the tutorial questions. So 2c, create a Python function for h of x given by h of x equals 1 over square root of 2 pi and this. So then make a plot of the function for x in -4, 4. Label the axis and save your figure as hx.png. Okay, so the first thing we do is to create the function h of x, small letter h of x. Now, we want to return this function. I would strongly recommend that you split this function into 2, okay, so that it will be easier for you to code. So you can say term 1 equals 1 divided by square root of 2 pi. So we have to import from numpy, import sqrt and pi. Then, so I think, is that okay? I think that's okay. Square root of 2 pi. That's term 1. Then term 2 equals exp. So we need exp as well. Exp minus 0.5 times x squared. Okay, minus 0.5 times x squared. So that is, then you can now say return term 1 multiplied by term 2. So I think this is very simple. Then the x, we have to make a plot of the function for x in -4, 4. So it means we also need to import a range, or we can use linspace in this case. We can use linspace here. Then we also need to plot. So we say import matplotlib.pyplot as plt. Okay, so let's get the range of x values. So x is from -4 up to 4. Now the number of points, let me start from a small number. Let's start from 10. Then I'll explain something. Then, so plt.plot x, comma, h of x. Let's use the spaced line and color it as blue. Okay, if you run this, you can see the graph is not smooth. So, but if you increase the point to 100, then it becomes smooth. Okay, I think Let me use red. Yeah, better. And you can even increase it to 200. That's 200 number of points. Okay, so now we have to label our axis. So we have to label, so plt.x label x, plt.y label. Y label is h of x, so h of x. What else? I think that's all. Okay, so this is the plot, but I think let's just use yeah, it's okay, it's better. Then we have to save the figure as hx.png. So you say plt.save fig. So the name of the figure. So they said hx, so hx.png. So if you run it again, the figure will be saved in the directory you are working. So I'm working in this directory. So this is hx. Okay. So this is the plot, h of x against x. Alright, so that's about that for now. So next class, I think we have to go to ordinary differential equation in next class. Maybe after that we'll look at some other tutorial questions. Okay, so see you later.